Let's go ahead and get it started. Good afternoon for everyone joining us today. My name is Rosendo Pili, and I am a STEAM coach at Nebula Academy. On behalf of my fellow STEAM coach, Thomas Carey, who will be leading today's session, I would like to welcome everyone to today's call and to the latest episode in our online learning series, Education and Collaboration with GitHub. I would just like to remind everyone to please remain muted throughout the presentation. We will be monitoring the chat for any questions that may arise. And with that being said, I want to thank everyone for using those features, both the raise hand and chat features that alert us to your questions. Simply hover over the screen with your mouse, and those in-meeting command options should populate along with the command bar. So at the bottom of the screen, you'll see that if you simply hover over the screen. All right, just to reiterate, today we will be discussing GitHub. We will be discussing education and collaboration with GitHub, and this has been presented to you by Nebula Academy. Just a brief overview of what to expect in the next hour and a half. We just want to acclimate you to the topics we will be covering moving forward. So just to go down this list, we will be giving a brief overview of what GitHub is for those who are completely unfamiliar with the platform or who've never used it before. We'll be giving a high-level overview before going into any of the specifics, just to get anyone caught up and kind of dip your toe in the water, so to speak. We'll be discussing the importance of GitHub, why it's so prevalent in the programming community, and why it's used so prevalently both with professional and amateur developers, and the importance of GitHub as a collaboration tool. From there, we'll be discussing the implementation of GitHub into your curriculum. If you are an educator, this is probably something that you are wondering yourself. What are the requirements? What are the challenges? And at the same time, we want to show you how the implementation of GitHub can ultimately improve the way we teach subjects like computer science. It's something that can definitely be used within the classroom setting. And yes, so in that section, we're just going to be covering how you can do that as a teacher yourself. Next, we'll be covering how we improve the way we teach subjects like computer science. So here we ask the question, can we teach computer science without teaching GitHub? Is it possible? Is it something that should be done? What are the best practices around that? And are we effectively incorporating technology into our classrooms? So here we're going to dive into the topic of real-world application. Are we effectively preparing students for the job market? We're going to be asking the questions of how we're actually building these real-life skills for students within these, advanced computer science or just regular computer science classes in the high school level. So here we're going to show you how GitHub can actually act as a resume for new programmers, how it can expose students to the online programming community at a younger age, and how it shows a demonstrated proficiency in a widely used industry tool. From there, we're going to move into collaboration with GitHub. So here we'll show you some of the ways GitHub actually empowers us to collaborate within the classroom, not only students with other students, but the teachers with the students as well. And finally, with that being said, we're going to go ahead and look into Github Classroom, which is a specific offering that allows educators to create a virtual classroom experience using GitHub. So, here we can track student development, track remote work, progress on any assignments that are ongoing, along with, increasing student accountability and productivity within the classroom setting, and, just basically allowing educators to have another tool within GitHub that further empowers them as educators. So I'd like to kick it over to Thomas, and he'll just get us started pretty much with the rest of the session. Thomas?
So we'll get started with the history. What is GitHub? Especially if you've never heard of it, you may have heard it before but don't know what it is. Git is a technology and GitHub is a platform. So that's a common thing a lot of people don't really know. They hear GitHub and that they assume that's what GitHub is. But there's other platforms. There's like GitLab, and you can actually host your own Git. But the thing you want to understand is that GitHub is a provider of the technology Git. So Git was invented in 2005 by Linus Torvalds during the development of the Linux kernel, so the operating system Linux. It was sort of one of these first projects that was a large project that had a lot of developers from all around the world, but they weren't all in one company. They weren't sharing an office space or sharing a server or anything like that. They needed some way to combine the source code of all these different developers from across the world in a convenient way, in a way that they could combine parts of code in a clear way to keep track of history of code. And it really required a technology to be built in order to get, this massive undertaking of Linux. And before this, I mean, internal companies have their ways of managing source code. Like inside a large corporation, they would have one server that had all the files on it, and then you would maybe pull down a file, edit it, and push it back up. But there was no real coherent way to, say, merge two different files, or combine the fact that maybe on my computer I move folders, I move files around, or maybe I want to try to do a little change, but I don't want to affect everybody else's code, right? I want to test something on my version. So this Git really provides this all-encompassing platform for working on code with multiple people and for multiple machines. So I even use Git and GitHub for my computer and my laptop. So my code, all my products live on Git, and I'm the only one who uses them, but it's still convenient for me because now I have a really nice way that not only keeps track of all my code in the history, but I can combine things from my laptop. I can work from my laptop for a little bit, walk upstairs, go to my computer, and all my code is there. I don't have to worry about any of it. I'm not dealing with file servers downloading, uploading, or anything like that. So yeah, so it's a really powerful technology, and it's also completely universal. So just so that everybody's on the same page, Git is used by everyone. This is not like this, like a text editor we're showing you, or maybe it's one way to do things. Git is the way basically everybody, even full-blown companies, will have swapped out their internal systems for Git in the past decade. So basically everybody is using Git, and that's kind of why we felt it was important to expose educators to this technology, because it's going to be something that students are going to be surprised by when they get in if they've never heard of it before. Because one of the first things I learned in my computer science curriculum at college was, here's how to use Git. We're going to use Git for a lot of things in the classroom. Make sure you understand it. And there were a lot of kids who had never seen it before. And I think it would not only give a good framework for using Git in the future when they run into it, but also expose the students to the community of GitHub, because GitHub is not only just for private projects, or I only want me and my 3 coworkers to work on this. GitHub is basically the platform for all modern open source projects. So that term open source, if you never heard that before, open source means anyone can view the code, and potentially anyone can also change the code. There are people who manage it, and they'll give permission to certain people to say, hey, you can change the code. But the idea is that instead of delivering a program, or compiling the program and then selling that compiled software, you can actually have everybody work on the source code from all over the world, all people who have different visions for it, and they can branch off and make their own versions, and everybody works on it, and everybody can view it. So open source is a really popular thing right now. It makes technology really easy for other coders, especially beginner coders, because what it does, it creates all this software out there that can do all sorts of different things and can augment your code, and all you have to do is pull it down from the internet, and it's wide open for you. It's free. Through Git, you have access to it. So that's also a really big component. For example, a lot of the web work that I do, there's a lot of stuff that 1,000 times have been written before. I don't need to rewrite a file downloader, because on Git, there's 1,000 other people who have written that code. So all I do is I pull it down, I add it to my project, and that is a core part of my workflow. And as a beginner coder, that makes things so much easier of understanding not only that culture. There is sort of that culture of coding, of making things open source, distributing things, being the one who kind of made this thing now everyone else is using. There's that cultural element, which is really, I think, a good thing to expose new students to computer science to. But also just practically, if I'm working on something and I'm new to it, it's so much easier than if I have to write everything from scratch if I don't know what I'm doing, than to just pull something down, look at it, see how it works, edit it a little bit for my uses. So I hope that gives you kind of an idea of the importance of Git, why somebody who's equipped with the knowledge of Git is much better suited to become a programmer, a proficient programmer in the future, especially starting at a very basic level. So that's kind of the idea of what GitHub is.
So Thomas, just to interject here, and to ask you a question, actually, personally, if you didn't know about Git, or if you had zero idea of what Git was as a programmer, in the modern day workplace? Like, how do you think you would fare?
That's a good question. I was not super lucky when I first started programming. I first started programming in Java, which does not have a lot of open source products out there for Java. Java is more of kind of one of those corporate languages, because I first started programming with Minecraft, and that was all Java. So what it really helped me with was not necessarily my first time coding, but moving from something like Java, which I learned when I was much younger with Minecraft and then in AP Computer Science, moving from that sort of worldview, which is I think what a lot of computer science teachers now, their view of coding is like, I write my Java class, I compile it, and then I have an executable and I can double click that, or I can run it and I get a command prompt. What the vast majority of like paid software positions today, especially coming right out of high school or college, is web. And without GitHub and the open source community, it would have been much harder for me to understand web technology, because it's so much compartmentalized. There are components from all over the place that make this web infrastructure work. Like the stuff I work on today, it's probably only 5 or 6% my own code. 95% of the code that I write is just libraries that somebody else has written, and that's all built on the back of Git. So definitely with more practical coding, I would say more, I don't want to say practical that like, stuff like Java or C# isn't practical, but more say like what you would build a business with, or what you would want to get an internship for. Most of that, unless you're doing like really mathy stuff like a finance internship, it's going to be JavaScript. It's going to be writing web stuff. It's going to be understanding that architecture. And that was made 1,000 times easier by my knowledge of Git and that community just existing. So
it sounds like it would be very integral for anyone getting into programming to have knowledge of Git, simply because of the resources available to them. And specifically within an educational environment, it just seems like there were so many resources available to you to learn more about JavaScript programming and just to see more, open source code.
So yeah, that's also knowing what you don't know. Like there's a lot of things that you just have no idea about. You won't know about it unless you stumble across it. And Git is this central location where there's all this code that you can just search around with and learn so much. And also just a place to explore curiosity. Like if you're just curious about, hey, how does Google work? You can just type in Google into GitHub and you'll get 1,000 projects that have to do with Google, they're add-ons to Google, all things like that. It's a really great place to just explore and just find things. So, and I think that's probably the key point in getting a student interested in computer science, is showing them that there is this massive like social network of developers who just love coding and love making things, and just inspiring that curiosity is what gets people down the path of learning, because you only learn so much in the classroom. A lot of coding is just learning coding, becoming a better coder, just sitting in front of a computer and doing it. And you don't really get there until you have the curiosity and the internal motivation to do that. So Git is also a really good way to spark that.
And I love that you said you don't know. That's knowing what you don't know, because that's literally what Git is doing. It's showing you the things that you don't know, so you don't have to go and reinvent the wheel, so to speak.
Absolutely.
Okay, I think that really takes us into the next topic. So what is the importance of GitHub?
So yeah, so I'm sure you can understand from how I talk about it that I think it's extremely important. But just so you don't take my, you don't have to just take my word for it. It is, again, everywhere. Not just individuals, open source people. Every company I've ever interacted with, I've ever worked for, I've ever, spoken to a developer on it, everyone's using Git in one way or another. Now, they may be using private versions of Git, where it's completely closed off. You can't just search up their company and view their source code. But even without that element, I mean, that's a huge part. There's so much value in there, but even without that element, it's so valuable and so inexpensive that basically everybody uses it. It brings an incredible amount of value just being able to combine code from multiple developers. And there's just so many different things that streamline the workflow and give you a really good perspective on what working as a developer is like. It's all centered around Git. And maybe we'll go in later a more concrete example of what that looks like. But because I think it would be a little too much to go over like the intricacies of how, and showing you exactly how it all works, because again, it's a very technical sort of thing. But once you understand it, you understand immediately the developer workflow. It's almost like the developer workflow like the modern developer workflow has been built around Git rather than Git around the development workflow. They worked off each other, and obviously the original development of Git was to work with how developers were working. But nowadays, everything is around Git. Like when your boss at a programming company says, "Okay, I want you to build a drop-down tab on page 7 or whatever of your website," which is like the most common I could get, the most basic request you'll get as a programmer. Maybe you'll have like a spreadsheet of all the things you have to do, and one of those things is just, hey, do this thing. Right? The first thing you're going to do is you're going to go onto their Git. You're going to make yourself a developer branch. You're going to commit to that developer branch. You're going to make changes to that developer branch. And once you're satisfied with it, you're going to show that to your boss on Git. They're going to look at Git. They're going to say, okay, this looks good. They'll verify it. It'll get merged into the production branch, the production code, and it'll go up on the web server. A good web example, but I don't want to make it sound like it's just web. Again, it's everything. Everything works like that. You have your own little branches that you work off of, and then you push it up to the main core source code, and that's where everything works. And that workflow, even as an individual, that's how I work. It's like, all right, I'm getting started on this new thing. I'll pull down a little local version. I'll edit it. I'll test it locally, and then I can push it up to Git. And then I have technology on Git's end that automatically detects that I've made changes and pushes up to the server. And that's actually its own field of that you can get paid to do, which is called DevOps, which is working with not the code itself, but the operations around the code and how getting code onto a server, or dealing with the security of who has access to the development environment, who has access to the servers. That is also centered entirely around Git, and you really don't have to write a line of code for that job. And that's all around Git. That's a paid job. I've met tons of people who that's their job. They get paid lots of money to do that for a company. So I think as an instructor, you should really be thinking of this like almost like driving a car. It's something that you basically cannot do any technology job in 2020 without understanding Git first. And that's why it's the first thing they teach you when you come into a real like boot camp.
Yeah, I can imagine how complicated code bases can get very quickly. If you weren't using a versioning tool, it would be pretty much like the Wild West, right? You have a group of 20 programmers and everyone's kind of working on different features on a website, and there's really no way to make all of those changes being implemented into a cohesive and uniform process. So visualizing the way modern day programming is working is even before, when a lot of the teams within the programming world were kind of compartmentalized or were kind of sectioned off from one another. It was almost as if one group of programmers were throwing some code over a wall to another group of programmers and seeing whether or not that would work with that group of programmers' code. So it's allowing for large groups of individuals in very complex and high level organizations, like undertaking very complex projects within programming, to collaborate in a more effective manner, to see each other's code, to make sure that they're actually implementing the features in the right way, in addition to the fact that none of those changes are actually conflicting with one another. So that's I think that's another huge part of Git, is the ability for you to collaborate without not only repeating tasks. So people are not just like, going over somebody else's work and doing it all over again. If it's done, it's done. And, the other part of it is like being able to push code to production a lot faster, because you have everyone's versions readily available to you. You can see, which ones you need to implement and when, and have like a scheduled timeline for those pushes, instead of, I guess, throwing caution to the wind and just like, merging everything into one thing and then pushing it out and then hoping there's no bugs.
So yeah, I would say, imagine it, maybe you've done this with your students before, if you've had them work in like groups of 3 or 4, where one student will work on a file, another student will work on another file, and then maybe student 1 realizes they need to make a change to student 2's file, right, in order for their code to work. So they do that, but then when they go to combine their files, student 2's code is going to override student 1's changes in that file. And that's like a fundamental, and maybe you've experienced that before, with a conflict and maybe some arguments between students who are writing on the same code base. What Git does is it basically takes all of those small little problems and streamlines them into not, it doesn't have a magic way of just saying, oh, this is the code I'm going to take, this is the code that you guys want, I just know what needs to happen. But what it does is it presents to the user, hey, there's a conflict here. Here are the steps to fix it. Here's the ways you can solve it. And it streamlines everything. It's almost like having another brain who's watching over all this code and says, hey, this thing came in first, then this came. You have to resolve these two files in order to make it work. Whereas what you would have done before is you just have a file server or even just somebody's computer. You write some code on it, you put it on a flash drive, you push it over, and then you personally, with no help, basically have to know, okay, this file came later. I have to make sure that it works with this file, and doing it all yourself. It sounds like something that's it's an issue, but it's not like a huge issue. Like you could do it, but it really is like such a small amount of effort to turn a project into a Git project, and a huge reward and just a really good experience.
And to kind of piggyback off of what you're saying there, as you mentioned, the amount of collaboration that's available with the use of GitHub, in addition to the conflicts being pretty much resolved almost automatically. It would just really take a little bit of oversight from the end user in order to decide which version to move forward with. There is also the possibility that one student makes a mistake that renders the code base a little bit inoperative, and instead of having to move forward with that same version of code, you can actually just go back and revert to a previous version of code, which is why collaboration with GitHub, it not only allows you to share your code with one another, for one student to actually view another student's code and work within a team and all of that, but pretty much it allows them to move forward in a manner that's not constricting their creativity, that's not constricting their ability to go in there and make mistakes and then have the ability to erase it. So you can always revert back to a previous version of your code that was working, that for a fact was working, and then you could kind of reverse engineer what went wrong with the later version of code, because you still have it there. It's still there for you to view, and it never disappears, because GitHub actually takes a working history of all of the code that you've ever committed to it. So this is one of the most powerful aspects of GitHub. As we mentioned before, it's essentially a versioning tool, but it's also a versioning tool that is available to you on the cloud. So it's, especially now as we're moving towards a more remote model, the importance of that is becoming even more clear. And it's the ability for students to not only collaborate within the classroom, but within the virtual classroom. And it gives them, as I mentioned before, the freedom to make mistakes and the freedom and the know-how to correct those mistakes in a programmatic fashion.
Yep, and also just an automatic backup system is a small thing. Like my computer explodes, all my code, all the history of all the changes to my code, it's all there. And just one more note on that of why Git is, it doesn't hold your hand. When I was researching the content for this session, I actually read somebody wrote something basically along the lines of the reason why everyone loves Git so much is as opposed to the more corporate technologies that were before, where those technologies basically said, this is the way to do things, that you have to conform to the way we do things, and then you're just going to follow these steps, and it's just going to work, and you're not going to see any of it. Git instead understands the way coding actually flows and doesn't force you to do anything in a specific way. It just gives you the basic tools to do what you need to do, and you can kind of do whatever you want with it. I mean, people have done, you can make a scavenger hunt with Git. It doesn't need to be constrained to programming. For a long period of time, I had all my homeworks up on Git. So that way I could have it on my computer and my laptop, and I could see history and have backups, and it was all up in the cloud. So it really is kind of just a general good tool, in the same way that a text editor is a good tool that you always interact with. It's a good thing to teach a student, and it's something that isn't really being taught right now. So
so improving how we teach. I think that's a great topic to jump to. It's the same thing, implementing the GitHub curriculum into your curriculum. As we mentioned before, there will be, certain requirements and challenges to this. It will all eventually depend on the way that your current classroom is set up, as far as what the students have access to technology-wise and hardware-wise, and whether or not they have, working internet connections, whether there are any constraints within your specific locality on the use of outside internet resources and Wi-Fi connections and whatnot. These are all hurdles that you can encounter when trying to implement GitHub into the curriculum of your school personally. This is going to be pretty much a challenge that you will need to face on a case-by-case basis.
What I'd like to do is maybe, Ro, you can kind of just list a few, because I know you're a teacher, you have experience moving classrooms from non-technical to technical. What are some of the big challenges that like immediately come to the front of your head, saying this is what needs to be tackled before we can even come close to implementing this?
Well, absolutely. I mean, I think there's a very skewed way with which the current education system is viewing technology and its implementation within the classroom. So right now we have, specifically within New York State, we have hundreds of Chromebooks floating around in these classrooms that are completely unusable for things like Git. And the students and the teachers are also required to actually teach computer science with the use of Chromebooks. And while, having technology in the classroom is always a good thing, I believe it's not always the case that technology is being used in the most effective manner, or whether the technology is even the right tool for the job. And as you know, it's not necessarily important to have tools. It's important to have the right tools. So for me personally, I see that as an obstacle. You can't implement Git necessarily with a Chromebook. You can't necessarily teach computer programming with a Chromebook. And as I mentioned before, it is an online resource. So like how would we overcome those issues?
So yeah, I think you touched on an important point, which is the issue of Chromebooks. I think as a general rule, it's very hard to accomplish a more accurate simulation of what real developers do in a computer science classroom with the Chromebook, because you're very strict with what you have access to. You only have access to a browser. You don't have access to a file system. You don't really have access to a terminal, which I think is also an important part of teaching computer science. It's really more of a limited, you're further away from the fundamentals of the computer when you're using a Chromebook than you are with even something like Windows, and definitely at least so with something like Linux. So, and it's something because I worked with my computer science department when I was in high school, and I was kind of there when we went through this transition from Windows desktops, Optiplexes all over the lab, to getting rid of all those, and now everybody has a Chromebook. And basically what everyone ended up doing was using the Chromebook and then using VMware to basically enter a virtual machine which was running Windows. Because that was the only way that the computer science classroom could get like a Java compiler. There's online Java compilers, but it's just you can't simulate a development environment without a file system, without being able to download and upload files to the internet. When you're trapped in the browser, there's very little you can do that comes close to what real developers do. And it becomes very much a roadblock in trying to emulate those kind of environments, which is why I've encouraged the computer science teachers in my district to push for just for the computer lab, because I understand the value of the Chromebook in things like history and science, because it's more of a note-taking device, keeps everything on the cloud, it's cheap, it's simple, and that's why the administration at these schools love these, because they're cheap, they're not hard to set up, it's just a password, and then it's all your online system. But when you're working with computer science, you need that experience with computers, and the Chromebook almost really isn't a computer in that sense. It's more like just a browser with a physical browser, like a phone or something like that. And even a phone can do more than what a Chromebook can do in terms of having access to the file system and running programs. So I've always pushed for, just for the computer science lab, to have access to some kind of hardware that isn't a VM, because it's much slower, it's clunkier, it can crash. Just something that you have access to testing out new pieces of software. Things like VS Code, things like Git, things like Minecraft Education Edition, all these technologies that are designed to help get you closer to kind of that getting. Really, that's what computer science should be, in my view, is this ramp into the industry, getting you those basic fundamentals. You learn how to code, sure, but there's 1,000 ways to learn how to code, right? And it's not going to, whatever, maybe 3 hours a week in the computer science lab, not counting the time it takes to boot up the machine and, chat with your friends and all that stuff. is not going to get you to a fully working programmer. What the computer science classroom really should be, in my view, is exposing students, sparking that curiosity, because the internet is so much better nowadays than really any classroom can at delivering massive amounts of information and providing all that information at your fingertips. And you're not going to be able to compete with that. So why do that when you can instead be the person who's exposing them to the technologies, exposing them to the higher level concepts, being that person who understands things and can answer questions when they come into them, but more so being a guide rather than some, just lecturing and going on, because they can watch 1,000 YouTube videos on how to code Java or how to code JavaScript or how to write in Python. There's 1,000 people who've done that, and it's will be much more deep than you'll ever be able to prepare in a curriculum for a year. So I think GitHub is kind of one of those things where you could, as an instructor, you can be that guide which exposes them to this world, and then they, with their own curiosity, with their own spark, beyond the basic, what you want to get, obviously you want to get the basics, but to launch them into that world of learning new things, of having access to this massive community of coders, this massive database of open source projects, and exploring that. Because me and, I'm in a computer science program. I know a lot of people who learn computer science on their own. Basically, the common experience among everyone is that APCS was nice, but what they really learned from the most was what really gave them the tools to get like an internship was stuff like Git. That's really what I'm hearing, and I know for fact I didn't write a line of Java in any of my jobs. Learning those concepts were important, but I learned that stuff before I got into APCS because I was interested in coding on my own. So what really equipped me with that ability was the ability to adapt. When I first got my first JavaScript job, I didn't know any JavaScript. But what let me be successful in that was kind of this openness to say, hey, I don't know what I'm doing, but I'm going to figure it out. And the internet, knowing how to use the internet, was key in that. And I think that sort of idea, again, of more being a guide rather than a teacher. And GitHub is a really good tool as a guide to say, hey, I'm the guy. Let me show you the doorway into all of all the experts. Here's all the experts. Here's all the stuff that's been done before. Here's all the masterpieces. Let me show you. Here's how you can go find them. And that I think that sort of attitude could really put you above the rest in terms of an instructor at computer science at the high school level. I think it's important to kind of understand that our goal is not to be the here's how to do step one, here's how to do step two. It's more exposing, being the guide. So yeah.
Mm-hmm. No, I absolutely agree. And it's going back to what you said earlier. It's knowing what you don't know. So exposing these students to all of the resources that are at their disposal is really going to be key in sparking their curiosity towards computer programming. And to answer the question, can we teach computer science without teaching GitHub? Yes, of course you can. You can teach it, but are you teaching it effectively? It's like teaching someone how to ride a bike and just showing them pictures of someone riding a bike. It's like, you have to show them the bike. You have to let them sit in it. You have to let them pedal the wheel, pedal and steer. So that's essentially what we're getting at here is not only it's possible for you to teach computer science without the use of GitHub. It's possible for you to teach, certain foundational aspects of computer science without necessarily having your students use a laptop. You can read them articles, you can have them read literature about it, but is it as effective as actually guiding them to the resources that they will be using on a day-to-day basis as professional programmers or as amateur programmers even? Like just anyone who is on the journey of trying to expand their skill set within technology, it's always going to come down to the fact that the people that excel the most within this field are the ones that are able to obtain resources and put them to good use. And the way you obtain resources is through the internet. It's through things like GitHub, and you don't know about them until someone shows you.
And not just, I just want to point out, it's not just like hardcore programmers who are going to be benefiting from this kind of this more undirected style. It's anyone who interacts with technology. I would say in particular, entrepreneurial type minds benefit a lot more from having access to these resources than just knowing how to write a for loop in Java, right? If you're going to be running a company, you're much better equipped to have a vision for that company, have a vision for the technology, have a vision for what's needed when you have access to Git than if you knew how to write a for loop in Java, because you may not be the guy who's writing the for loop. You may be more the visionary, the more that type of person, or really anyone in the entire pipeline of the software business. They're going to be much better at their job knowing Git than if they knew the specifics of a certain language. You know, that's kind of the point. So let's get into what are the specific requirements of incorporating GitHub. Mainly, it's going to be moving group projects away from just 3 people sitting next to each other on a computer or on 3 different computers, and actually implementing Git and Git repos for those groups. So we'll get into this in a more detail when we get to GitHub Classroom at the end, which is a really nice implementation of this, which does a lot of the work for you. But if you're interested in just kind of diving into this, I would suggest go on GitHub. And maybe we'll, again, towards the end, if we have time, we'll do like more in-depth walking you through that stuff. But there is also, you know, again, just like everything else, so much online resources. This is more just showing you this is an important thing. Look into this. But yeah, so getting GitHub repos, repositories, which is kind of the name. You may hear that a lot when you do your own research. Git is built around repositories, which is like folders almost. You can think of it. The shared folder, just like you know, in OneDrive you have your shared drive. The repo is the shared folder that has all the code. So you may have many of those. And what I would recommend is maybe making one of those for each group, and then each group kind of has this shared folder on Git that they can develop their code. And then eventually what you can do is not only can you keep track of it live while they're making changes, but when they're finished, instead of having them print out the code, like that was how we did it in my computer science classroom, was they literally printed out their Java, you know, and then the teacher would go over it, highlight things with a marker, you know, you'd have to print down your output, like to prove that it worked, instead of the teacher testing it themselves. And I think just as a kind of modernizing it, not just making it, because I know there are teachers who prefer working with paper, and I totally empathize with that, so I'm not like against printing it out or anything like that, but there are a lot of really nice things that Git lets you do. Not only having instant access to everyone's code, being able to clone it, test it, or even test it in the web in some cases. You can actually run tests automatically without having to have to download the code yourself. You can put automatic tests that will automatically say, hey, your code's working, and grade it even without you having to do anything. That's That's basically 100% of what the coding does in my college computer science program, is that they have automatic tests. Now they still do grading of like styles, things like that, and maybe things that are hard to test. But most of the testing, the teachers don't really have to do anything. You just upload your code to a Git repository or online somewhere, and it runs the test automatically. So, and then also doing things like marking. You can highlight things in Git, and they'll get a notification. The students will get a notification. Hey, this has been marked. This has been highlighted. This is, you know, your code has been graded. So this stuff can all be done online in a really nice way with Git. So yeah, so I would look into just like experiment on your own. In the same way that we're not going to be able to just magically make you an expert in Git, you're not going to be able to magically make your students an expert in Git. Get exposed yourself with these tools, and then it'll become very clear to you quickly, not only how to implement it, but why this stuff is, you know, really valuable.
Yeah, and I agree. I mean, the more you use it, the more you'll see how it's going to simplify your life as an educator, specifically for those teaching computer science. And, you know, specifically for those of you who are, you know, trying to build a more collaborative environment within your classroom, and specifically with coding, it's going to make your life a lot easier. And at the end of the day, it's going to enrich your students and empower them to pursue these careers within computer programming in the future, or to simply pursue, you know, higher level education within computer science. It's going to kind of build a great foundation for them to move forward, and not only to move forward, but to have the mindset where they're actually searching out these resources on their own, and they have that mentality that they're not waiting for information to be spoon-fed to them. They understand that there are sources online, and that there are other resources available to them that they can go out and search and actually help to improve their own base knowledge, and also improve their code. So I think Thomas said it earlier, a lot of the times he's writing programs and 96% of the code is not even his, or 94% of the code is not even his. It's stuff that's already been made. So why even reinvent the wheel? It's going to give them a lot more bandwidth for innovation and for creativity. And at the end of the day, that's really what we're trying to do, is just empower you to become a guide for your students so that they are, kind of going down this path in a way that's most beneficial to them. So
this is an element that you may also not have known if you don't know about Git, but it's a whole new thing we haven't talked about, which is that Git is not only a public place for people to view your source code, but your profile on Git can immediately shows anybody who looks at it, here's all the things you've worked on. Here's all the places you've committed. Here's all the things that you've done. Here's all the recommendations or commendations you've gotten from people commenting on your code, problems you've solved for people, and just anything you've worked on. It acts as this really, really nice portfolio as a software developer when applying to internships or companies or even to college. If you can link them a GitHub profile, which shows that you've been actively working on things and actively making code, it's a really, really good way to demonstrate, proactive and intelligent programmer to someone who's looking at applications. So another really good thing to note, as terms of preparing your students for the real world, as sort of a first step towards a programming resume and building a portfolio, just linking their GitHub profile and using the same GitHub account for all their stuff, whether that's in your classroom or stuff they do on their own, just compiling all that stuff. It's a whole other element of GitHub, which is almost that social network element, where anybody can kind of recognize anybody else on the platform. And yeah, so it's really powerful to be able to say, hey, all of my students in my APCS, they now have not only experience with Git, they know how Git works, but now they have a Git profile that they can send to colleges and even jobs later, saying, here's the stuff that I've done.
Mm-hmm. Not only that, I mean, you can also deploy your projects from GitHub with something called Github Pages. So in addition to building an online repository of all the code that you've written up to date, you can also specifically deploy applications on just through the GitHub website, and they'll give you a URL specific to that application, and you can share that with people, and they can actually view the work that you've been doing. So it's not, I mean, I've heard so many stories of people telling me, when I was going to AP Computer Science, I built like a tic-tac-toe game in the terminal, and that's amazing. It's great because it shows you how to work with logic. It shows you how to, render output to the terminal, but it doesn't translate in today's world in the sense that, having a link to show someone and having that link populate to an actual application that's live on the web, it's going to have a completely different reception than, this is my code inside of the terminal. So, it's giving students not only resource to store their code, but it's also giving them an outlet to display what they're capable of and to showcase their skills. So it's extremely important in that sense, in terms of providing that proof of work and consistency, and just every day it shows you, like, basically there's a calendar that shows you how many commits you've made in a day and how long you've been working on specific projects. Just in essence, that's what GitHub does, because it is a versioning tool and it does take a history of all of the things that you've done within a specific code base. It not only does that, but like I said, it also gives the students a form of validation in terms of, I worked this hard and this is the end product that I came up with. So it's really powerful, not only in building portfolios, but in building up the self-esteem and in building up the, the excitement towards computer programming for, the individual student.
And that's also another, GitHub Pages is a good place for just hosting a custom resume. That's also a really good exercise, is you can basically just have a website built out of nowhere for free on your Git account. It's really basic. It's also a really good lesson plan, kind of teaching basics HTML. So it really is almost this environment of all the sort of modern, or the culmination of all modern technologies in deploying applications, being able to distribute information, distribute technology to people. And you can use all these tools to build lesson plans, and also to give the students powers to show other people, hey, this is the stuff I've done, rather than just you being the one who say, oh, wow, this is a nice tic-tac-toe, it works really nicely or whatever. Now, what if they could host that and they could link to somebody else and say, hey, this is something I made, and that would maybe encourage a little more creativity. But so yeah, just another angle to come at it from.
So I mean, in addition to that, everything that we've mentioned thus far provides real world examples of working code. Employers want to see, is this student actually implementing code in a way that would be useful to us as an organization. In addition to that, it provides demonstrated proof of collaboration. So it's not just building up the skills that the hard skills that you need to be a computer programmer. It's also building up their repository of soft skills. Are they able to communicate technically? Are they able to communicate empathetically? Are they able to communicate at all with other team members? Do they work well with others? And it's all going to be there. Do they have the managerial sense of being able to kind of dictate a workflow that works for them and their colleagues as they're collaborating towards achieving, the specific goal of whatever project you've assigned? These are all like extremely important skills that are going to be useful to them, not only within the classroom to succeed at the curriculum that you're providing them, but also to succeed in the real world. And I think that as educators, what our focus should be is providing a curriculum that is going to be most useful to the students in the long term. So I can't tell you how many times I was in school and I was learning the Pythagorean theorem, and I was learning how to measure a slope in parabolas and things like that. I felt that I would never actually use in real life, and that's what I constantly ask myself, is like, when am I ever going to use this? And I think that effectively teaching computer science, incorporating certain mathematical skills to it, incorporating certain things from physics, incorporating other subjects into your computer science curriculum with the use of GitHub is actually going to effectively answer that question for them. This is when you apply it. And as long as you actually, and it's just helping you to create a curriculum that most closely resembles what they're going to experience as programmers in the real world. So I think that's it's definitely something to keep in mind, and I feel like it's something that we should always be kind of exploring and asking ourselves in the back of our heads is, are we preparing them? What are we preparing them for? And is the content that we're giving them preparing them for the real world? And is it going to make them successful in the real world?
Just to reiterate, Git is designed for collaboration. Mm-hmm. It is a technology entirely around being able to say, hey, I wrote this line of code, I wrote this line of code, I wrote this line of code. So I know what a lot of teachers fear when they're, learning about Git for the first time. I was like, oh, well, if I put them in groups, it's just going to be one kid writing the whole thing. But that's really not the way it works, not really the way it can work, because sure, you can have, one person push up, a fully working example, but other students are still going to be able to pull that down, have that on your computer, and experiment with it. So, obviously, just like you would with anything else, you would want to put like, hey, one person works on this. We don't want to have one person writing the whole code. But I mean, it shows you exactly who wrote what. So you know exactly, I know this is a problem that in my class, in my high school CS classes, where like there would be a group of 3 kids. There was always one guy who was writing the whole code. And once they handed it in, there was no way for the teacher to know who wrote what. But with this, you know exactly who wrote each line. It gives you a lot more power. And then you'll be able to say, hey, you can only write this stuff, you only write this stuff. I want to see more collaboration. And being able to communicate, be able to name, give declarative comments on what you've written, being able to view those things, see when they happen, see how they happen. So it gives you a much better tool to see how collaboration works. Mm-hmm. And as a teacher, to address any of those issues that maybe some students are not doing enough or some students are doing too much. I think this platform gives you a lot more power, even though it is remote and anything that you could do it from anywhere. It's like almost easier in a way. It's also easier for you because you know exactly what is going on at all times.
Mm-hmm. And yeah, to to just add on that, it's not just about the students collaborating with one another, but I think another way of looking at it is you as the educator collaborating with your students. So how are you proliferating assignments? How are you how are you giving the students the source code to whatever assignment you've just recently given them to work on over the weekend? You can literally have a repository in GitHub, send everyone a link, and have them fork that repository, and then they could just work off of whatever starter code that you've already provided them, and submit their projects to you via pull request. So and these are all specifics that we're going to get into a little bit later on when we demo GitHub to you guys, if we do have enough time. But for the most part, the more you familiarize yourself with the platform, the more use cases you're going to come up with to meet your specific classroom needs. And I think that's yeah, and I think that's the crux of it, is just being able to what we're doing right now is just trying to guide you towards the resource and show you what it's capable of, and hopefully as you move forward with the technology, open your eyes to how it can be even more useful and usable for your classroom specifically. So
yeah, I think that really that's kind of our sales pitch on GitHub, why we think it's important. Again, it's a free software, you don't have to pay anything for it. We just really want to express how important it is, especially for new generations of programmers, to learn this stuff before they leave high school. And hopefully also encourage you to learn some newer stuff if you have, been out of the loop for a while, and just kind of get a better understanding of how things really work and the cool new ways that modern programming has got around a lot of issues. So with that, I think we're ready to move on to some of the more practical stuff with the remainder of this. Again, if anyone has any questions, we'll answer them as we go, but we're going to go over GitHub Classroom, which is a very practical, kind of does a lot of the stuff for you way to build a classroom in GitHub, invite students to assignments, and run tests and distribute grades and stuff like that in a really easy way. So without further ado, we'll get into that. So all I'll do is I'll probably share my screen for this part. Okay, so here's GitHub Classroom. It's basically a platform designed for teachers in a way that makes it very, very easy to build assignments. What I'll do is I'll go through a very basic example of assignment and just kind of show you what this looks like from the inside. So I'm going to sign with my GitHub account. I already have a GitHub account, and I've got two kind of test classrooms here. What I'll do is, just make sure you have a GitHub account. It's just a basic email login, stuff like that. I would look into, if you're a teacher interested in, there are services. GitHub is owned by Microsoft, and Microsoft does a lot of stuff working with public school districts and providing them with the tools they need. So there's definitely, if you're really interested in implementing this in your classroom, I would reach out and try to integrate your domain, your school domain, with GitHub. That way every student automatically gets a GitHub account and you don't have to walk each person through the sign-in process. And also that account will then be used as kind of a portfolio and stuff like that. So a good thing to think about. So here's GitHub Classroom. I've got my GitHub account logged in. I'll do a new classroom. And then there's an organization. So again, if you'd like to get it set up, you can also just create an organization yourself and name it after your school, but you can also work with GitHub as the district and you'll get like a district-wide group as well. So this is my group. I've named everything kind of test, so I'll name my classroom. So you can set this wherever you want. Maybe you can name this like AP Computer Science 2020 or Spring 2020 or whatever. And this will basically keep a record of all the assignments for that classroom. And so you can invite TAs and administrators, so you can invite users as assistants. So you can go here and then basically choose team members and invite them directly by their account or their email. So that's how you do that. But if you just want to, okay, so this link you can send to students. There's a couple ways you can do this. This is kind of the easiest way, is just send them all links and they can click on this link, they'll automatically be in the classroom. But what I found really cool is that you can actually pull in all your students automatically from Canvas. So I know that's the platform my school used. And if you do this, you can automatically integrate all the students who are logged into your Canvas, and then you don't have to worry about it. We don't have a Canvas, so we're not going to do that part. But if you walk through this part, you would get, you would just connect, just as simple as connect your Canvas account, add all the students who are in your CS class, and they'll automatically get accounts, and they'll also be access to the classroom. So let's see. So then you can also manually add students. So this is kind of just adding students. How do you get students into your classroom? And once you've done that, once you have students, you go to create your first assignment. So you'll make sure you have students all set up properly. TAs and admins have the right permissions, and invite all of them. And you can go ahead and create your first assignment. So what I'll do is I'll just make this like a hello world Java, I'll say. And you can set a deadline, which is also kind of a nice little feature. It will close after that deadline. And then this is really cool. You can make it an individual assignment, meaning it'll go out to every individual student's account, or you can make a group and actually build, just configure what the groups are yourself, or make them random, or whatever you like. So again, we're not going to go into every little detail, into every example, but just showing you that there's something that exists, and it's certainly a lot easier than trying to cobble this together all on your own. So there's that. Obviously, most of the time you probably want to keep this private, but if you want to keep it public and show other people, you can. And then this is kind of just a setting. If you understand what Git is, you'll know what this means. But if you don't worry about it. Let's see. So this is also really cool. So what you can do is you can give a base repository as, like, say you didn't want them to start from scratch. You wanted them to fill in only a certain part of the code, or you wanted them to build out from a framework and maybe only add a certain class. Like I know what a lot of teachers do is they'll provide the client code, meaning like the code that will receive input from the terminal and then produce the output, and that will call the code that the students write. So you can build a repository that just has that client stuff, and then that will be the starter code for all the individual students' repositories, and then they can edit that. So that's a very powerful thing, and I think will automate a lot of the hard work that teachers do to try to make that work on their own. And there's also online IDs. So again, if you're using Chromebooks, you'll only be able to use online IDs because you can't download anything. Certainly, I think it's a better experience for a student trying to learn what real engineers do to use something that's more in the computer, something like Visual Studio Code or anything like that. But yeah, you can just do an online ID. You can automatically connect it with online IDs, so it automatically appears in their editor. So we'll go here, and then here is the part where you can add tests. So this is really cool. So you can do an input-output test. So I could say like, and the run command would this is kind of like what my teachers would do in APCS, just automated. So what they would do is they say, well, if you type in this word, I expect this word, right? Like the palindrome is a good example. So there was like a palindrome product that I have to do. And maybe what you would do is you'd say, okay, if I type in, let's see, big house, or what would it be? It would be, I guess you would do run. This would be like if you were running in Python, I guess. This would be like the command to run the actual code and then the input and output. So I think with Java, you'd have to write like a terminal command to run the Java code. I can't quite remember what the syntax was, but like this would be to run. Maybe it would be like something like that. If you work with Java on the command line, you'll know what that means. Basically, just execute the Java file. And then maybe if I type in big house, then I expect like fail, right? Because it's not a palindrome. And I will save this, and then I can add another one. So similarly, if I run the palindrome code base, and maybe I have another one, maybe like this. So I expect that to succeed because that is a palindrome, right? And you can do things like this automatically, and now once you set this up, you don't have to do anything else. All you have to do is say, oh, this failed, this passed, and of course you'll want to go over their code themselves and look through it. But you can all do this in this one area. You may not even have to print anything out. You can just put the grades in, give their grades back through Canvas, and ready to go. And this is also really nice. This is a pull request. Pull requests are a kind of a complicated feature on GitHub that maybe won't go into full detail, but basically what it lets you do is add a comment to a code and say like, this is what I'm thinking, what are your, accept it or deny it, right? And you can use that to give feedback to students if they have questions. And I think this is a very powerful thing. I know this was a very common situation where the times when a student would be writing code was not necessarily the time when the teacher was available. So this is, again, you can ask questions at any time. It's an online platform, especially in the more mobile with COVID and everything, people being away from each other, it's a lot harder to get FaceTime with teachers. If you could just ask questions through this, it makes things a lot easier. So yeah, so this would be the basic idea. Then maybe I'll just go through what pushing to this repo would look like. Let's see. So let's see. I'm gonna paste this link. So now, okay, so this is me as a student basically. So I'm also the teacher, but I can also make myself the student by just joining it as a student. So if I click this link, I can join as a student. You can also just disable the link if you don't want it, but that's fine. It may have changed. So let me just try the new link. There we go. So now I can either accept this assignment or deny it. Obviously, I won't get any points if I don't accept it, so I'm going to accept it. And then what this is, Git is automatically building a repository for me. And then it's going to import the starter code that I added. I didn't add any starter code, but great. So here we go. So now I'm going to just go through. I'm actually going to use the Visual Studio Code stuff because we had a session on that if you want to check that out. And it's also just makes things really easy. So let me just do. You know what I'm going to do? I'm going to pull down this first. So I'm going to pull down this repository. So this is a repository URL. So this is the link to a specific repository. I can click on this and I can view the files in the repository. So again, it's like a folder up in the web. So this is in here. This is I can view all the behavior. I can see the commits, and this is all kind of like a demo stuff. And now what I want to do is I want to pull this down. So I'm going to clone this down. I'm going to go into my command prompt, go to my desktop, git clone, and you'll have to make sure you have Git installed on your computer. Again, don't want to go into too much technical detail because it's a lot of extra knowledge. You have to know like how to use a terminal and all that stuff, and we don't really have time for that today. But hopefully this is a good guide if you're coming back to it, or if you just want things to look up. This is kind of the path of what a real developer will go through. So, okay, I'm starting my project. I want to get that onto my computer so I can start working with it. I'm going to clone it. So I'm cloning the repository right from the web down to my computer. I don't have permissions on this. I think I need to go into my Linux system. So just ignore me for a second. Great. So my Linux system has permissions to. Okay. So it's hello world Java. So great. So this is my code now, and now what the teacher expects is for me to write a Java program in here that can detect whether or not something is a palindrome. So I'm going to go into Visual Studio Code, open up that folder, and we'll go into my desktop, hello world, and select that folder. So now I'm working in this folder, and I have the Java add-on. So if you can go to, just so that we're complete here, I have the Java extensions for Visual Studio Code that lets me work with all that stuff. So if I do right-click new file and name it palindrome.java. So this is my Visual Studio Code environment. I've cloned down the repository onto my computer. So now I have it in my computer. So you can see this .github folder is here and it's over here. So let me just get this done. How did we do this last time? Did we finish work? Yeah. And then I'll just write some Java code real quick. Am I missing something? There we go. Case-sensitive Java. There we go. So now what I can do is I can just do basic things like if I'm writing it for the first time, I just want to make sure this is all working properly. And in VS Code, I can do kind of these nice things like just run this from within and I can see it's all working properly. Hello world, great. So let's Let's see if I can remember how to do this. I think scanner is just static, right?
Scanner system in, maybe.
Oh, I need to, yeah, I need to give it a parameter, right?
Yeah.
Okay, great, yeah. Shouldn't have given myself such a hard programming task. I don't remember how to reverse. I don't remember how to reverse strings at all in Java. So maybe we'll just pretend that I do this properly. You know what? I'll just have it. I'll have it do like. Is this? What's the syntax for this? Like I said, it's been a while. Been a long time since I've done. Let's see. Scanner. Ah, it's just next line. Okay. Okay, so that'll read in, and then I'll just say, I'll just have this be a broken piece of code that always says fail, right? And then I'll do run. That'll work. But anything that's a positive test case is going to fail. So now that I've got this up, what I'm going to do is I'm going to do the basic git commands to get this up onto the repository. So I'm actually going to have to be in my Linux. So let me actually share my full screen now so you can see this. So you don't have to be in Linux to do this. It just so happens that only my Linux thing has the credentials to do this push, because you have to be logged in with the same Git account you're using on the online. And I'm only logged in on my Ubuntu system, but it's the same exact thing as it would look. What I type here is going to be the same exact thing you would type in Windows. So I'm going to be inside this folder, my repo folder locally. Git add dot, so that'll add everything that's called staging in Git terms. I'm staging everything to be committed. Then I'm going to commit this. So I'm saying I'm confirming these changes. This is not going to, I don't want to undo this. Well, I can undo this, but I'm going to lock this stuff in for now. Just a little description about what I did. So now this is committed. And then in order to push it up onto the internet, I'm going to do git push. So that'll run. It'll do some uploads. And now if I go to my Git repo and I hit refresh, there's my code there. And I can click on this and I can see exactly who wrote it. And it's all by root, which is me. And I can see exactly what the code is. And there's actually some cool stuff. They've got like code navigation now, which is kind of nice. And now let's see if I go to GitHub Classroom and then I go to refresh. See, latest commit failed, so I can go to the test. Boom. So my auto grading, this is my auto grading window. Oh, it's because there's no Java command. Shoot, this is awkward. Well, I think it would be a little too much right now to go over why this particular command failed. Maybe we should have come up with a better test case. But anyway, the point is, if you set this up in the right way, this can be configured to do everything for you. That's kind of the point. So never mind this like detail thing of like, oh, it doesn't know what .java is. If you can test things on the same way you would test it on your computer, you can test things by configuring this, and it will do everything for you, and it will make your life as a teacher a lot easier. And you'll get this nice UI. You get like all this, you know, so you can do a feedback pull. So this is all like a feedback comment board that other students can write comments on and discuss things. So all contained in this application is basically everything you could possibly want as a teacher for having your students collaborate, work on code together. Yeah, I think it's a really powerful thing to learn as a teacher. Hopefully this has kind of given you an insight into why this is valuable. And despite my failure on this testing system, it's a pretty small part of it, and it really is really easy to get started. Maybe later down the line, we'll do a session going into detail of how to build repositories if that has interest. But really the point of this was to show you, hey, this is something that is completely universal in industry. It's not super complicated. It's something young people can learn and actually have to learn. Like I had to learn this at a pretty young age. You know, my first year of college, so that's only what, a year, 2 years for some people after AP Computer Science. So I think students are definitely more than ready to learn this stuff now. It's not super technical. It's just kind of getting the concept of how it works. And once you do, it totally clicks. And then as a teacher too, just exposing yourself to this environment, to the culture, and spreading that to your students in the form of cool lessons, a good collaborative environment, and also just engaging them with the coding culture on the internet, which is just super powerful. So.
Yeah. Absolutely, and yeah, I wouldn't look at it as a failure, more so as a demonstration of how the platform actually does work. I mean, in theory, if we had the right run command in there, obviously the tests would have automated. But it's, it just goes to show you what we did in 15 minutes. Obviously, is going to be something that you spend a little bit more time on as an educator in creating your content for your students. This is just another way for you to automate that process and another way for you to proliferate the curriculum that you are currently teaching to your students. And it just becomes more and more important as we transition more into a remote model for learning. It's going to be something that I believe teachers can get ahead of the curve on and kind of implement before trying to play catch up with other people's curriculum. You're now the one that's at the forefront, kind of suggesting the way to actually move forward in spite of having to socially distance, in spite of having to teach everything remote. So I think, yeah, it was definitely a great way to showcase it. And I think Thomas is. I
think I found the right one. Hold on.
There you go.
I think I can get this working. So let me just make a small change so I can commit this again and run my. So there have been changes, so I need to pull it down. So my update that actually changed the, see the autograding.json changed. So that's really cool. So yeah, so this is all stored within the repo, which means it can be compartmentalized, which is really awesome. Okay, so let's see if that works. Let's look at the, and see if that worked. Pound your own Java. Did I spelled it wrong? No. I got this. I just spelled it wrong. There we go. I want it to be, might need to be uppercase. I don't know if this is case sensitive, but I'm just going to try just in case. Let's just hit delete on that. Okay, let's see if this works. Okay, so it's still the old test cases. Pull down those changes. Make a quick change so I can push it again. Let's see if this will work. It's still the old one.
All right, so Thomas, we actually do have a question in the chat.
Oh, great.
Kristen asks, she sees the value of GitHub, but she's required to use Google Classroom. Is there any way to push grading back out to Google Classroom?
Oh yeah. So if I go to new classroom and I just choose my group with this, so this is all within GitHub. I set this up and then I go to the page where I integrate all my students. You can see Google Classroom. And this will actually have me log in with all the accounts, all my Google accounts, and it'll associate the Google accounts with your Google Classroom. So you can actually log in your Google Classroom with this and not only will it bring in all the students from your Google Classroom, but it will also push grades back through Google Classroom if you set it up in the right way. So yeah, and there's tons of good documentation. Let me just link some stuff. There's a lot of good documentation that GitHub has published. This is a really good link to start with. Let me see if I can. That's a really good link to start with, just as a branching out to kind of search out through different things. And again, if there's interest, we'll go through more depth. We'll do a more in-depth session, but we're kind of limited on time. I think we've only got maybe 10 minutes left on this one. But yeah, so you can definitely do that. I encourage you to try it and just experiment with it.
Okay.
And see what the things will.
And just to add to that, Kristen, the link that Thomas is referring to is now in the chat, so feel free to go ahead and grab that up for yourself. It won't be, I don't think it'll be accessible after we close out of the room, but I hope that answers your question. And I also do want to remind everyone that this recording will be made available moving forward, as well as the deck and any of the resources that we're currently providing. So just something to keep in mind.
Yeah, so I think that's everything in terms of what we wanted to cover. Mm-hmm. Unless there's any other questions, I think I'm happy with what we got done.
All right. And Kristen says, awesome, thanks. Thank you for your question. And yeah. And yeah, it looks like we've pretty much covered everything. With that being the case, unless there are any other questions regarding any of the topics that we covered today, that's pretty much, let's check the chat. There looks like there's some activity there. And okay, so Kristen asks, if you were going to suggest one thing to start, what would you recommend we start with?
I would say Google Classroom, the GitHub Classroom is a really good way of getting the environment set up, but you'll still have to learn how Git works in order to teach your students. So in that case, what I would recommend is, I mean, Google's definitely going to be your friend with learning anything on it, and it is a good experience just to like, hey, I want to try to learn something on the internet, here's how to do it. But I could definitely suggest some content for GitHub for beginners. So this is a really good, it's kind of very similar to what we did, except it goes into depth of like directly how to use it rather than what it is. So here's, I'll link that. So that's kind of how actually Git works and how you would work with it. So that's a good read if you want to understand like the direct, so you can teach your students how to work with it. And then for the classroom element, I think GitHub Classroom, even without reading anything extra, does a really good job of guiding you through the process of building everything. And then combine that with your knowledge of how Git works, I think it'll start to crystallize really quickly. And at least will give you a really good jumping off point for maybe looking up other things that you need help with down the line.
And as Thomas mentioned earlier, we are definitely open to coming up with more sessions that do go a little bit more into detail about the nitty-gritty in terms of setup. And yeah, Kristen says thanks, very helpful. And yeah, we want to continue to be helpful. So it's definitely something you guys can consider reaching out to us and letting us know what kind of content you want us to cover moving forward, specifically within GitHub or just anything else involving, maybe Microsoft Teams, VS Code, things that we've covered in the past, things that you maybe want a deeper dive into. We could definitely, kind of get into the details of those processes and yeah, show you guys like, actual pull requests, maybe doing stuff back and forth between Thomas and myself in terms of just like general GitHub usage, maybe how you would use GitHub within the terminal, how you would be teaching those topics to your students. And yeah, whatever you can think of, it's definitely something that we would like to create content for your consumption. So, all right. And if that's all for the questions, and it seems to be, yeah, I guess we'll just leave you guys there. It's 3:55, so like we mentioned before, we'd like to give you back that 5 minutes and get you underway for the long weekend. And we do hope that you've enjoyed today's session on GitHub education and collaboration with GitHub. And yeah, any feedback you have is welcome, and any feedback with regards to any future topics that you would like us to cover is once again equally welcome. So with that, yep, we we'll leave you guys to it. Have a great day, and we hope to see you for our next session.
Bye, everyone.